Okay, I have discussed this concept of planetary boundaries before elsewhere, at least once, if not more. This is a paper that talks about how 6 of the 9 planetary boundaries have been breached already. So Earth is beyond 6 of the 9 planetary boundaries. If you don't know what they are, you will know in a minute because we'll look at a figure. This planetary boundaries framework update finds 6 of the 9 boundaries are transgressed, suggesting that Earth is now well outside the safe operating space for humanity. So global mean things are looked at for biodiversity, nitrogen cycle, water, various things we'll see in a minute, 9 planetary boundaries. And then some assumptions are involved in defining safe boundaries. We'll see one example in a bit detail, and something like ecosystem integrity, for example. What does it mean? There is a definition. So you have to really worry about the meaning of having globally average nitrogen cycle limits for safe operating space, let's say, and the global mean will be exceeded or breached because people are doing different things at different locations. Rich countries are doing something, poor countries are doing something, and you are averaging and saying, oops, we crossed this in a global average. So how do you translate it back into action at local scale, because everything has to everything has to occur at local scales to feed back to the global planetary boundary. That's a very tricky thing. So obviously there are controversies about this, but without worrying about those, this planetary boundaries framework update finds that 6 of the 9 boundaries are transgressed, suggesting that Earth is now well outside the safe operating space for humanity. Doesn't also tell you what the consequences are of breaching this or transgressing this boundary. Ocean acidification is close to being breached, while aerosol loading regionally exceeds the boundary. So what are the consequences? Ocean acidification, has there been any quantified impact that says we are really outside the safe operating boundary? And the same for aerosols. And aerosols are very challenging because there are global transports, but they are produced locally, and there are sinks where it drops off. Either dry deposition or wet deposition are very local. So what does it really mean? Because aerosols have direct impacts on blocking sunlight, for example, and then they have indirect impacts on cloud microphysics, and even think of health and other impacts as well. Stratospheric ozone levels have slightly recovered thanks to Montreal Protocol and Kigali Amendment. The transgression level has increased for all boundaries earlier identified as overstepped. As primary production drives Earth system's biosphere functions, human appropriation of net primary production is proposed as a control variable for functional biosphere integrity. So this needs a definition. We'll see what is defined as the original author, who is sitting here, Johan Rockström. And maybe if you look deeply into this, you will I see one Indian name, and maybe there are some Americans, but this whole business of planetary boundaries tends to be dominated by Europeans. Does that say something? In some sense it does. Who puts priorities on what about portraying climate change impacts does depend on where you come from. So biosphere integrity boundary is also transgressed. Earth system modeling of different levels of the transgression of the climate and land system change boundaries illustrates that these anthropogenic impacts on Earth system must be considered in a systemic context. Very good. There are interactions and feedback, so we have to think of it within a systems framework and cannot look at just one thing or the other. So let's immediately look at the biosphere integrity as a definition, because the other things may be more obvious. Myriad interactions with the geosphere make the biosphere a constituent constitutional component of Earth system and a major factor in regulating its state. I've discussed Earth system in great detail elsewhere. The planetary functioning of the biosphere ultimately rests on its genetic diversity, inherited from natural selection not only during its dynamic history of coevolution with the geosphere, but also on its functional role in regulating the state of the Earth system. So plates have moved and they've been together and apart, and speciation, species evolution, ecosystem evolution, and so on have happened, and nutrient cycling also involves geology. So geosphere and biosphere and the climate and the Earth system as a whole have all co-evolved. So genetic diversity then and planetary function, each measured through suitable proxies, are therefore the two dimensions that form the basis of a planetary boundary for biosphere integrity. As applied here, integrity does not imply an absence of biosphere change, but rather change that preserves the overall dynamic and adaptive character of the biosphere. There was a very, very general framework. So how do you measure, for example, adaptive character of the biosphere? Is it a global thing? It's a local thing? The overall dynamic and adaptive character. So dynamic is, let's say, how you respond to environmental changes, and adaptive is, let's say, genetic ability. So there are mobile generalists which can move, and sedentary specialists which cannot move. An ecosystem doesn't move, species move, so ecosystem gets fractured, so integrity is lost, let's say. Rockstrom et al. Defined the planetary boundary for change in genetic diversity as the maximum extinction rate compatible with preserving the genetic basis of the biosphere's ecological complexity. So we are using many words here. So we said biosphere integrity, and then we are saying biosphere's ecological complexity. Sometimes people use ecosystem health, which is like biodiversity, overall productivity, and resilience. So nothing is unique in this way, but we have to look at this anyways, because it has some value in tracking these things. You always want to be able to monitor and evaluate the impacts of human beings on climate, and climate impact on species and other planetary operating spaces. So here you have biosphere integrity. It's genetic and functional. We'll leave it there. Climate change in terms of CO2 concentration and radiative forcing, but you have other greenhouse gases as well. Novel entities, which is defined here. Let's look at that. Maybe I'll add that definition in the next podcast. Stratospheric ozone depletion. It's within the safe boundary and has recovered a little bit, so we are in the safe operating space. Atmospheric aerosol loading. It's still within safe space, but the ocean acidification is headed towards the boundary there. And biogeochemical flows of nitrogen and phosphorus are red, means there are in the high risk zone. And you have freshwater change, green and blue. So green is the surface water, I think. Blue is what comes down from the atmosphere. So they are in the zone of increasing risk. Let's say land system change heading towards high risk. So this has already been mentioned. So current status of control variables for all 9 planetary boundaries. 6 of the 9 boundaries are transgressed. In addition, ocean acidification is approaching its planetary boundary. The green zone is the safe operating space below the boundary. Yellow to red represent the zone of increasing risk. Purple indicates the high risk zone where interglacial Earth system conditions are transgressed with high confidence. So basically, since the last ice age in the Holocene, we are already beyond the safe operating limit once you accept that definition. Values for control variables are normalized so that origin, and so there are some details of the size, the length, and so on and so forth. I won't go into those details, but there are lots of assumptions and lots of data have to go in there. How they are globally averaged is also tricky. If you want to read a bit more, current status of the planetary boundaries, I won't read all the details. That's a lot of information there. So you look at Earth system processes like climate change. So you track control variables like CO2, greenhouse gas, and anthropogenic radiative forcing, so how much additional energy you are trapping. And planetary boundary is assumed to be 350 ppm, and 1 watts per meter squared is the safe operating space for additional forcing. Where did these numbers come from? That's not at all easy to be very objective about. Pre-industrial levels, upper end of the zone of increasing risk. We are at 425 or so now, and increasing every year by 3 to 4 ppm. And current value by when its paper was published was 417, and the forcing was 2.91 watts per meter squared. But this is complicated with greenhouse gases doing something, aerosols and land use doing something else, and so on and so forth. Change in biosphere diversity. Biosphere integrity, we looked at genetic and functional. So this is measured as energy available to ecosystems in terms of net primary production, percentage of human appropriated net primary production, and so on. Planetary boundaries in billions of tons of carbon of human appropriated net primary production, pre-industrial values where we are now, and so on. Stratospheric ozone depletion, we are in the safe space, as we said. Ocean acidification is measured by carbonate ion concentration, because as you increase CO2 dissolving into the water, the chemistry says that carbonate ion gets consumed, which makes it harder for shell forming animals like corals and others to form shells, and you begin to have negative impacts. Okay, and we are approaching the safe operating boundary at this point. Biogeochemical flows of phosphorus and nitrogen cycles. So metrics include phosphate global level, nitrogen at global level. Again, these are highly local, and these estimates are global. How was it done? You have to figure that out, right? It's not easy, because getting data is hard, and then aggregating is easy. Disaggregating to say where are we most likely to be able to take action to avoid going further from the safe operating boundary, or even to come back towards safe operating space. Because ultimately monitoring is one thing, but translating these into action, mitigation is one thing, but adaptation is another thing. Since we have crossed nitrogen and phosphorus safe operating boundary, what can we do now? So land system change is looked at globally. Area of forested land as the percentage of original forest cover, biome area of forested land as percentage of potential forest. So there are model estimates of what could be the maximum cover of forest we could have. There you have to consider other factors of population, food security, etc., etc. Okay, so few more. Land system change I already mentioned. Fresh water change, so blue water, human induced disturbance of blue water flow, and green water, so human induced disturbance of water available to plants, so percentage of land area with deviations from pre-industrial variability. The baseline of pre-industrial is already something that you can quibble about, because do we really have solid data to claim what it was? CO2 is very easy, but how easy is it to look at blue water and green water before industrial revolution started? It's not very easy. Atmospheric aerosol loading, another difficult problem. Interhemispheric difference in aerosol optical depth is looked at as a control variable. And novel entities here include percentage of synthetic chemicals released to the environment without adequate safety testing. Okay, so let's see how long I am here. It's already 14 minutes, so maybe I'll stop this here. I can keep going and make these podcasts 30 minutes long, but generally the attention span tends to be 10 to 15 minutes, so I prefer to cut them off at some point and split it into multiple podcasts. So let me come back and try to conclude this thought on transgressing the planetary boundaries as defined by the original paper of Rockstrom et al. Okay, so it's useful, and obviously it's something that can be done, should be done, despite all the uncertainties and subjective definitions. But again, next step has to be about what actions can be taken to stay in the safe operating space, or how to come back if we have transgressed, and what the impacts are of the actual transgressions. Okay, so let's come back and conclude this discussion.